Good morning. It's Mrs. Hebert from the Syracuse Academy of Science and Citizenship. Today in fourth grade math, we are in week 6, day 5. We will be starting a new standard for MBT 6. And let's go ahead and read that. We can find whole number quotients and remainders with up to 4-digit dividends and 1-digit divisors, using strategies based on place value, the properties of operations, and or the relationship between multiplication and division. Okay, let's start there. So today we're going to use the strategy called place value dis. This is something you should be familiar with. They probably introduced it in 2nd grade to you, okay, your teacher. And I'm going to also, on the second problem, show you how to connect it to the standard algorithm, okay? All right, so let's look at our equation. We have 96 divided by 3. Keep in mind the answer to a division problem is the quotient, okay? So when we get our quotient, it is going to be smaller because we're dividing up this 96 into 3 different groups, okay? We want to know how much does each group hold. So 96, I know that I have 9 tens, 2, 3, 4, 5, 6, 7, 8, 9. And I know I have 6 ones. 1, 2, 3, 4, 5, 6. I'm intentionally doing 5 groups at a time because that is similar to a 10 frame, okay? So here we go. We need to now know how many groups are we going to break it into. 3 different groups. So let me make my groups. 1, 2, 3. There we go. We have 1, 2, 3 groups. Perfect. Now, next step, okay? We need to say, I have 9 tens. How many would each group get? Well, I know that each group would get 3, 4, 5, 6, 7, 8, 9. And I can show you something you may have done in the younger grades, or even last year in 3rd grade, when you were dividing, you had your 3 groups. Okay, and then if we did 1, we could cut it out. 2, 3, 4, 5, 6, 7, 8, 9. So it shows you 3, okay? We have 3 of them. Now, next step, we need to make sure we cross, oops, excuse me. Get rid of that circle. We need to make sure we cross off all of them that we used. So we used all 9 of them. We have no 10s left. Then we move on to the ones. If you remember, we have 6 ones. How many would each group get? Okay, we could do it one at a time. 1, 2, 3, 4, 5, 6. Again, we used all of them, so cross them all off. Now we have our quotient. So 96 divided by 3, each group has 3 tens and 2 ones, 32. Now we can also, and what we should do as great mathematicians, check our work. And if you can see the relationship between division and multiplication is the opposite. So now we're going to multiply to make sure that we got that correct answer. Okay. So my quotient was 32 times our 3. So if we did it correctly, we want to get 96. 2 times 3, 6. 3 10 times 3, we get 9 tens or 90. So the answer 96. Yes, correct. Okay, I'm going to show you one that's a little tougher. All right. So we have, if you notice also, this one is going to be your freebie from your exit ticket. Okay. Here we go. We have 352 divided by 2. And I'm going to connect the standard algorithm along with it as I go. Okay, so we have 300s. Oops, you know what? Let's make it a little bigger so we can see those dots. There we go. 2, 3. 5 tens. 1, 2, 3, 4, 5. 2 ones. 1, 2. Now, first thing we're going to do, we need our groups. How many groups do we have? We have 2 groups. You just cut it in half. We got 1, 2 groups. Next step, we are going to break up those hundreds into our 2 groups. Okay, and let's do so evenly. We have 1, 2. Now, if you notice, I could only use 2 of them. I have a leftover 100. So I want to show you what we would do. This 100 right here, oops, let's get rid of my line. This 100 is the same thing as how many tens? Does anyone know? 10 tens. Good. So we're going to bring over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And don't forget to cross it off. Okay, so I'm going to kind of go back and forth now and show you. So 2 goes in to the how many hundreds? 1 time. Okay, and if we look, we have that 100 left over. Okay, now we have 15 tens. 5, 10, 15. Okay, so as you see how I go through. All right, so now let's break up our 15 into 2 groups. Well, if you know 15 is an odd number, so 2 will not go into it evenly, but what's the closest we can do? 7, because 7 times 2 is 14, right? So almost 15. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Don't forget to cross off. So we use 7 in the first group. And then we use 1, 2, 3, 4, 5, 6, 7. Okay, if you notice again, we have 1 left over. Okay. Let me make this smaller so we can do it. There we go. And 10 tens is the same as how many ones? Yep. You should have said 10 ones. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, let's go back to our standard algorithm. And I want to show you that we have, ready? 2, 15, each group has 7. We use 14 of those 10s, and we should have 1 10 left over. Now, if we did this correctly, we should have 12 ones. Let's see if we're right. 5, 10, 11, 12. See how I did that groups of 5? It makes it easier also adding. Okay, now I have 12 ones in 2 groups. You should know, right, that each group, what's half of 12? We get 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. We use all of them that time. I'm just going to cross them off like this, okay? So there's no ones left over. And we can prove that over here. Okay? The 2 goes into our 12. Each group should have 6. We used all 12. So when we say 12 minus 12, 0, nothing is left over. We have no remainder today. So our quotient is 176. And like I said, we're really good. We're going to check our work. 176 times 2. Our goal is to get this answer here. 6 times 2, I know, is 12. I'll carry my 1. Oops, excuse me. 7 times 2 is 14, plus 1 more is 15. Carry my 1. 1 times 2 is 2, plus 1 more is 3. Beautiful, 352. We checked it. We know we did it correctly. So this is how our place value discs connect to that standard algorithm that we will learn eventually, okay? All right, have a great day. Go ahead and complete that exit ticket. This was your freebie. I'm excited to see your work. Have a good one. Mrs. Hebert saying goodbye.